Charbone had an interesting day today in the stock market. The stock was up 36% on more than 1 million shares traded. And at some point, it was up over 50%. And it's because of one reason. And that's because of the chart that Daniel and I are going to discuss today. In other words, people are truly learning the upside behind Charbone. So I asked Danielle Charette to join me and discuss more in detail some of the numbers in the chart so we can get more comfortable and get confirmation from the company. So Danielle, thank you for joining me.
Thank you for the invitation again, Mariusz.
Yeah, so the first thing I wanted to say is, I guess what we're learning and getting a better idea about Charbone is that you have 5 phases for the Sorrel Tracy project, and maybe the 5 phases for other projects, but we'll just discuss that one because this is what you provided in the financial presentation, in the investor presentation. But some of the numbers that I'm looking at is, phase 5, 25 megawatts, a certain production, certain sales that you projected, and then certain EBITDA or the profitability. So let's go through some of the numbers. Like, I don't know where you want to start, but I'm very interested in the sales number. How do you come up with the sales number? Can you somehow support it?
I guess one of the first things that we did 4 years ago when we started looking at the green hydrogen production was the cost of producing that hydrogen, which is kind of the OPEX of the project, because the CAPEX, whatever type of hydrogen you will be producing, you will have always a certain CAPEX. So in the case of electrolysis, what was really important, it's the cost of the energy used to produce the green hydrogen. So one of the first steps was to compare the different way to do the electrolysis, where to put this project. So we did a search in Quebec, in Newfoundland, in Manitoba, where the cost of renewable energy, and I would say mainly the base load energy, because we want to be connected to the grid to have a 24 hours, 7-day supply, 365 days. So that was one of the first things. Then the second thing is, as in a very old life where I'm coming from, I was using industrial gas. So I did had some knowledge about where do we buy that gas and how it would be delivered. So we did some market research and market analysis, and this is how we came with the pricing that it was actually the gray hydrogen, the dirty hydrogen, was sold from our future competitor, I would say. And since then, we are looking always at the market to see the price. I think the disconnect is coming from the people that are using dirty hydrogen SMR, which is generally primarily all consumed in place for refinery, ammonia production for fertilizer. And this gray hydrogen is very cheap. So when the point where both hydrogen become at the same level is when you have transportation. So the market price for Charbone at the gate has been based on what the other competitor were selling it for.
Okay, so what kind of prices were they selling it for?
I guess when you compare those individual cylinder, and this is where the story started, when we started looking at really initially, with the small production that we would start with when we started the Sorrel Tracy project, we were starting with a 0.5 megawatt electrolyzer at 200 kilogram per day. So at that time, our main pricing was based on smaller quantity of hydrogen sold in individual cylinder. And the competition right now is selling for about $70 a cylinder. And now it's a little bit more because my numbers are outdated on that one, probably 2 years. They were selling it between $70 and $75 per bottle. That bottle contained 0.5 kilogram of hydrogen, which means that delivered to the customer, it's $140 per kilogram. So it's true that electrolysis is more expensive than the SMR. But at the same time, hydrogen is a very difficult product to transport. Right now, pricing that we are seeing in US, and we have prices to back it up. I did receive a price in Missouri for gray hydrogen at $16 US per kilogram at the gate, plus $5,000 for delivery, which make the cost of that kilogram in the range of $40 per kilogram. So depending where you look at our pricing, Charbone pricing at the gate is $15. And this is what we've been calculating. So the point is, how do we compete against a giant company that will have a super hub, but which is distant of about 1,000 miles? The only way to compete against them is to go on a more network approach, localize nearby the end users, and reduce the price of our transportation. Now, the other factor in it is the cost of electricity. So we are shopping around all the time to find the best price for the renewable electricity. So our cost of OPEX goes down, and then we could be even more competitive.
Okay, makes sense. So when I'm looking at your phase 5 numbers based on 25 megawatts of electrolyzer, I'm looking at sales of about 56 million, which means you are selling the 1 kilogram of hydrogen for about $17. I think that's your portion after Superior takes theirs. So really, you are selling it for about $34 per kilogram. Am I correct?
I think the transportation part of it is another story which we don't have any influence. People are taking the problem on the opposite side. The agreement with Superior Propane is not a fixed number. It's a number based on the market price.
So explain this number based on the market price. In other words, what the end customer pays after the transportation cost?
Yes. So if the market cost actually, and I can certainly show you, maybe if you allow me to share my screen, I have a small table. Okay, these are the kind of prices that we did receive. So right now, when we are talking about bulk, right now there's some delivery, like you see on the middle of my screen. The price at the top of the table, they are the small units. So those units contain basically less than 1 kilogram of hydrogen. They are those individual gas cylinder or pack, which actually are sold on the market in a range of $72, $78 delivered to the customer, or even some bundle pack, which consist of 16 cylinder. So the price per kilogram delivered to the customer are pretty much in a very high range. Then we got one pricing that we did receive from one of our future customer, that it has been quoted for bulk gray hydrogen and not even green hydrogen. in Winnipeg, Manitoba at $35 per kilogram. Now you have to remember that Charbone is proposing another facility in Selkirk, which is 45 minutes away from Winnipeg. We have another customer in Prince Edward Island that received a bulk pricing for $85 per kilogram delivered from US Northeast. We don't know exactly which one. The two green lines are the prices that we've been seeing at the pump on a per kilogram basis, actually. And the Quebec market for the bulk, these are prices that we did received from other producers of green hydrogen or byproduct. So the pricing is kind of a line of what we've been stating.
Okay, but in the phase 5, you say that this would produce about 3,600 tons of green hydrogen production per year. Now, so when you were showing the prices, you were showing prices of like individual units, but if you produce this much, almost 4,000 tons, can you find enough customers for this much volume at such pricing?
Actually, I don't have all the number for the North American market, but only in Quebec, there's actually a production of above 40 tons per day of dirty hydrogen. And we do aim to take a small amount of this on a daily basis, actually, and migrate those dirty hydrogen to green hydrogen. So the point for us is, how do you move and decarbonize those industrial sectors? Now, remember what I said at the beginning of the discussion. People are mixing the price that a refinery, which would be Shell, BP, Exxon, that are producing on site for their own uses large amount of hydrogen from natural gas at a very low cost. But that hydrogen is never sold into the market. But when you do the statistics and you include those into hydrogen production, that's lower the price that we are seeing on the market. The market is there. Our production is a mix at the beginning, I would say, not at 25 megawatt, is a mix of individual cylinder, bundle pack, and bulk that will be delivered in a radius of less than 100 miles. Not like those large companies that are delivering at 1,000 miles away, where after 3 hours of driving, the transportation cost is higher than the content.
Okay, so so we kind of addressed the sales and the revenue. Now let's address the costs, which you kind of addressed, the access to stable cost of renewable energy. But the reason why I want to talk about it, because when I talk about something like putting something in production, it reminds me of mining company that says we're going to put this project into production and it's going to cost us this much to produce gold, but then after they actually put it into production, like the costs are like 10 times, and so the whole project doesn't work. So then I'm looking at this, oh, they have nice projections, but how accurate are these projections? Like, is this like a mining company or is this like something else?
It's a great question, and it will be a simple answers. And I always compare green hydrogen production as wind energy. I did spend the last 25 years in wind, and there's a lot of comparison that can be made on that. But that said, we are not the inventor of electrolyzers. In Europe, they've been doing it for 5 years and over. So the model that we are taking is already at some point existing in Europe. We have already purchased the electrolyzer, so we know the cost of the electrolyzer. We already purchased the compressors. We know the compressors. We already purchased the storage, permanent on-site storage tube, and we know them. We already purchased all the individual cylinder and the bundle pack. So all the CapEx and all the costs, we understand and control. The other part is construction. Construction, we already had a lot of expertise and a lot of experience through all the proposals that we received. So we did understand the budget on how was the equipment would cost, what the construction would cost, and how this will end up into commissioning. All the systems that we've been acquiring are modular, meaning that they are all packaged and all factory tested before reaching the site. So we have less than 4 to 5 weeks to connect all those modules mechanically and electronically. And again, it's not rocket science, nor that the hydrogen is used for rockets, but the production of electrolyzers has been made over the last 100 years. So as we do alkaline to start with, not PEM, which is more with major power electronics, the system is pretty simple. And we do, I would say that each week I'm receiving new proposals for electrolyzers. Right now we are shopping for 2.5 megawatt, 1 ton per day. We already have prices and proposals for 2 ton and 5 ton per day electrolyzers. We do have from a very large German company 57 million prices for a 50 megawatt complete plant. So we do understand the cost of the CapEx. Now, the OpEx, we understand from the performance and the capacity factor and the spec of each of the individual manufacturer of electrolyzer, how much kilowatt hour we need per kilogram of hydrogen. And we do have a table where we can calculate the cost, precisely the cost of all the kilowatt that will be used to produce that 1 kilogram.
Okay, so you're not like a mining company. You have a better idea of what the costs are. Okay, so for one more second, let me go back to the revenue part. So when you were sharing your screen, there were different prices. Some of them were $100, some of them were 30 something. So let's say if you have a customer that will buy 1 kilogram of hydrogen for $100, with Superior, you would go 50-50 on that, right?
Correct.
Right. So then you would receive a revenue of $50 per kilogram, and Superior would receive the other 50 if the price was 100. Okay, because the numbers here on phase 5 with the number of 56 million, it uses $17 per kilogram. So I just want listeners to understand it's $17.
It's an average.
It's an average.
It's an average. It's a mix of, it's simpler to understand when you have a phase 1, which is very low in production. So you will do approximately, I don't know, if I base my number in the very old project that we had 4 years ago, it was like 200 kilogram per day. So in a trailer, you can put 160 kilogram on a class 1, the very old one. Then you still have 40 kilogram you can put into bundle pack or cylinder. So there's a mix out there on, you can compare this as a pie. So what the portion of packaging or formatting in individual cylinder, in bundle pack, in bulk. So what's the average price of that hydrogen? That one is more difficult today to split when you are starting talking about 25 megawatt, because at 10 ton per day, you cannot transport on a gaseous form all that hydrogen. You need to liquefy it. So at 25 megawatt electrolysis, there is 7 megawatt, which is used to liquefy about 8 to 9 ton of hydrogen per day, and transport it with tankers that will be holding 4,000 kilograms of hydrogen, and will allow you to transport much more hydrogen, because a tube trailer on a gaseous class 1 is about 160. Some class 1 new tube trailer, like the one Charbone is looking at in Texas, will have 250 kilograms at a higher pressure. Now I'm shopping out new class 4 that will be able to hold 600 kilograms of hydrogen. And if I'm going into liquefied, then I will be able to transport in a single trailer 4,000 kilograms. That will reduce the price of my transportation at a very low cost.
Okay. Now, when you were also when we were talking about the accuracy of these numbers or projections, you were talking about how you understand your capex. So give me a ballpark of what it would cost to build up to phase 5, 25 megawatts.
Actually, it's about in Canadian dollar, it's about 100 and if I remember correctly, it's $135 million Canadian. And remember, it's not only 25 megawatt of electrolysis. It's also with 8 ton per day liquefaction. 5 ton per day liquefactor cost in the range of 30 million.
Okay, so if it, and I assume all of your numbers for the financial projection is in Canadian dollars.
Yes.
So if it costs 130 million to get to 25 megawatts facility, how are you thinking in terms of financing it? Like if you come into somebody and you pitch them the financing, how do you pitch it?
I guess right now the financing pitch is not my pitch. The way I'm pitching my facilities to the community where I'm going in is we are having 16 independent projects that are owned today 100% by CHARBONE Hydrogen Corporation. In order to get some of the investment tax credit that are both sides of the border in Canada and US, or certain production tax credit, you need to check many boxes. Some of them are depressed economic areas. Other are visible minority shareholders. So when we approach some of those communities, whatever it's in Manitoba, in Nova Scotia, in Wisconsin, in Michigan, in California, in Arizona, we are looking at, or even in Detroit, we are looking at the community by itself. We are an ESG-based company, and we want to have the local community acceptance, but also participation into our projects. So there's two ways out there. Some of the local investors in the project could be local stakeholders, and then they could be big brothers or large capital corporation that would come and would take a share in the project, or simply do project financing. So there are multiple options that are all different for all those projects. The beauty of the project is we are trying to do a copy and paste for 16 projects. But like you said earlier in the conversation, maybe some of the project may have only 3 phases for different reasons. And maybe some areas could have 2 projects. And right now, there's a lot of talking about
You mean two?
the
You mean
project.
2 phases, right?
No, I mean 2 projects
Oh,
with
some
3
some
phases.
areas might have two
Yes.
projects. Okay.
Yeah, like in Quebec right now, we did announce Charbonne Sorel-Tracy and Bécomo. So in Detroit right now, we are working 2 different projects, one in Oakland County and one in the city of Detroit, just beside the new bridge. So those 2 projects are too far away to be able to economically be able to deserve the same market. But maybe in California we'll end up, because Los Angeles is so wide, that you may need one in north, one in south. So the point for us is to have a network of facility that are opportunistic on the availability of interconnection and power, cost of electricity, and be nearby actual users of hydrogen. So those are the 3 criteria that we are always keep in mind.
But give me a scenario of, of how, let's say, you build out a project and you get project financing money to do that, whether it's from the city or local businessman or whatever. How much of an ownership would a Charbonne retain in a project that's financed by others? And I know it changes from one-to-one and negotiations, but just I think it's useful to have that conversation.
I guess as an investor myself in Charbonne, I would like my company to keep a minimum of 51% of all the projects. And I would think that Charbonne would be the owner and the operator of all its facility. And at some point, maybe we could own some customer as well over there. So again, going back to the concept that we put on before, because all the project that we are proposing right now, and specifically to Sorel-Tracy project, this is a facility that I call the multi-user facility. So we have a distribution company that will be distributing this hydrogen to multiple users in different formats. Charbonne also is offering single users facility. So when we talk with a steel mill, with a concrete factory, when we talk with an aluminum facility, these guys required so much hydrogen that it will not work to transport. So we would be offering them on a long-term contract to build a facility adjacent to their sites. But this is kind of the next generation, I would say, of Charbonne, because those will be very large and very expensive. Going back to how this will be financed, I guess it's project finance. How much money do you need to finance 5 million, a 10 million project to start with? So you may need 30% cash and 70% debt. There are some program available in the States, in some of states, I would say that at the level of the state, to get guaranteed loan on some equipment. There are some in Canada as well. So there are many forms to get financing for those projects.
But I would think that the first financing is going to be hugely important, because right now Charbonne is we are a company that promises to produce green hydrogen. But I think that after you show to the world that you can produce on whatever scale, whether it's 2 megawatts or 2.5 megawatts, then you can show them the economics behind it, and then you can be like, see, if you give us more money, we can replicate this 10 times.
Correct. This is the way we want to do it. And I think the key point and the key milestone for Charbone use the first kilogram of hydrogen to make the proof of concept. There have been a lot of thoughts and a lot of talks on big is beautiful, big is cheaper, but there's a report that has come out in January from Hatch, which is one of the largest engineering company in the world, stating that there were no economies of scale to produce green hydrogen at 500 megawatt. And I will understand that simply. A stack of an electrolyzer is a stack. So 1 megawatt stack will produce about 50 kilowatt, it will produce 1 kilogram. If you just multiply the number of stack, that doesn't change anything. Does it change something in the capex? I don't think so, because you need more compressor, more equipment. Everything is 1-to-1 and everything is mostly linear. What will not be linear is the balance of plant. It's the cost of fencing a big site versus a small site, building a larger substation versus a smaller substation, the parking lots, the building. This is the only thing that you will have maybe economies of scale. But as a 1 megawatt stack will only be producing that amount of kilogram by the input of kilowatt, whatever the number of stack you have. So if anyone wants to build a big hub, that's fine. But remember, a big hub means longer delivery time, much higher cost of delivery than delivering locally.
Okay. Now, when it comes to going from, let's say, 2 megawatts to 25, it's not just a matter of equipment. I think you also need permits and approval from the city to do that, and you also need enough electricity to support that, right? So how do we, like, where are we in terms of the permit from the city, and in terms of, do we have enough electricity to support that 25 megawatts?
Actually, Quebec, if we talk about that Quebec project, we have a permit from the provincial government to go up to 5 megawatt today in our end. For the construction permit, the drawings are already finalized and are in the process of being approved. And the only thing that I'm missing right now, it's a go from my contractor. For the 25 megawatt of power, Charbone has a request of power at Hydro-Quebec right now to be approved. And that will be known within the next, I would say, couple of months, as we need to plan like 6 years in advance not 6 years in advance. To complete that 5 phases, we need to apply much in advance because they need to upgrade power lines and substation. And it's not only in Quebec, it will be the same in other jurisdictions. So right now, as an example, I'm in final stage of site selection in Detroit. So as of today, I sent back an email to the Detroit Regional Economic Development with 3 sites that have been identified and selected, requesting the local utility to tell me how much megawatts are available at each location to start, and what will be the number of months required to increase at each of the phases the capacity of the sites. So I would say that each jurisdiction are totally different than any others. Here in Quebec, it took about 3 months of study and about 3 months to receive my permits. For the next phases above 5 megawatt, I will not have other study to apply for, but I would like to do what we call a BAPE, and that means that it's kind of an environmental assessment where the public will have to come and say, okay, here's the plan that Charbone is proposing, answering question. When questions are answered, I got my permit. That is not different than any other jurisdiction. The only thing that could be different, I would say, is if I'm comparing with Texas, where Texas may have a 2-week green hydrogen project permitted, California, it could be 3 years.
Okay. Thank you for this. So I guess the final question that I have is, you are operating, or you will be operating in the industrial green hydrogen market.
Yes.
What do your clients use the hydrogen for?
Right now, the experience that we had in a prior life, I had personally some customer using already hydrogen back 30 years ago. So they've been using it in aerospace. So for what we specific heat treatment on aviation engines, like GE Aviation, Pratt & Whitney will use, and other subcontractor of those, they will use it as well as what we call plasma coating. So they will be applying titanium coating and ceramic coating at very high temperature using hydrogen as a higher flame. You will have, of course, fertilizers, petrochemical users, semiconductor, and the new thing around the block will be heavy transportation at different levels. So whatever is class 8 trucks, train, marine, port, airport, logistic. So there are many applications that are coming, but Charbone really concentrate on that small amount of actual industrial users that are using it for different industrial processes. At the same time, we are working to develop a new ecosystem where we are partnering with academics that are looking at replacing natural gas in certain processes by hydrogen, or even other gas that are used for different process. I forget to mention semiconductor. There's a huge market for a higher grade of hydrogen, which is called grade 6.0, that is used, and I'm currently looking at upgrading my purity to that level to produce some quantity of hydrogen. So that will be at probably at a higher price, because it's a higher purity of green hydrogen.
All right, let's finish it on this. Thank you for the interview.
Thank you. Bye.